Alright, hi everybody. So this is just going to be a quick video to finish up acids and bases. There were two slides that I didn't get to previously. The first one was on buffer systems. And a buffer is exactly as it sounds. A buffer system is going to be where the system resists changes in pH. So let's say, for example, that you had an aqueous solution that had a pH of 7. And you want to maintain that pH of 7. You would have to have things in the solution that would resist changes to pH. Well, what are substances that change pH? The two substances that change pH, the two ions, are H plus and OH minus. And so you would need some type of substance inside the aqueous system that would react with these ions and take them out. And one of those things that you would need would be a weak base. So if we had H plus, and if we had a base around, a weak base, it would react with the H plus and sort of sequester it. It would keep it out of solution. If we wanted something in the buffer that would react with OH minus that we would add, well, that would be something like an acid, like HA. But it would have to be a weak base or a weak acid. How would the weak acid react? It would form water and A minus. Now, why do we care about buffer systems? We care about buffer systems because they are really important in biological systems. Two examples that are biologically based: blood. Your blood actually contains a very complex buffer system that has something called bicarbonate in it. The bicarbonate ion is able to react with any H plus that may enter the bloodstream and form another acid that is much weaker than the H plus itself. This H2CO3 then can break down into CO2. Your blood needs to maintain a pH of about 7.4. If you do not have a pH of around 7.4, the enzymes that are in your blood will start to break down. That would be really, really bad. If you do have a situation where you actually have too much acid, it's a condition called acidosis, and it's very dangerous to the well-being of, like your blood chemistry. Another example of buffers are lakes. Any body of water that contains organisms, plants, sea life, algae, they have a very complex buffer system that's built in. And you see this with your fish tanks as you try to replicate that. When you have to test the pH in your fish tank often in order to make sure that it's maintained. And when you want to adjust the pH, well, then you don't add a strong acid or a strong base, you add a weak acid or a weak base, and you create an artificial buffer situation. Now, the last thing I want to talk to you about are indicators. Indicators change color depending on what the pH of the system is. And so they are listed in this table here. A few important things to note are you need to know litmus and you need to know phenolphthalein by heart. Those are on the SAT too. But this table gives you all of these indicators, and there's a lot more than just listed here. These are some common ones. How do you read this chart? Well, look, let's take methyl orange, okay? So if we look at methyl orange, why do they call it methyl orange? Well, between the pH of 3.1 and 4.1, it is orange. If you put methyl orange, the indicator, into a solution that's below 3.1, they tell you in the chart here that below 3.1 you would be red. And you'll see that here, that you're red. If you put methyl orange into a pH that is above 4.4, you're yellow. So methyl orange has a color range between red below 3.1 all the way down to 0. It turns orange between 3.1 and 4.4, and then above 4.4 all the way to 14, it would be yellow. Bromethymol blue, let's do that one. Bromethymol blue, it is yellow when you're below 6. And it's blue when you're above 7.6. Well, what would it be between 6.0 and 7.6? Well, if we mix those two colors together, yellow and blue, we get a green color. And that is what you would have between those two. All the indicators on the table can be read the same way. Phenolphthalein will be colorless below 8. It'll be a very light pink between 8 and 9, and then it will be a dark pink above 9. Litmus will be red below 4.5, purple between 4.5 and 8.3, and blue above 8.3. Bromecresol green, yellow below 3.8, blue above 5.4, green in between. Thymol blue, yellow below 8, blue above 9.6, and then green between 8 and 9.6. Alright, well thanks for watching. What I'd like you to do is try some of these practice here, and we can go over those in class on the next time that I see you. Alright, thanks so much. Bye-bye.